One thing that is cool to know is that distance equals rate times time. So let's just read this problem here. We'll kind of go over this example. Two trains leave the station at the same time, one heading east, and the other west. The eastbound train travels at 75 miles per hour. The westbound train travels 95 miles per hour. How long will it take for the two trains to be 442 miles apart? Do not do any rounding. Okay, so if we write down the rate and time for each eastbound and westbound, we have 75 and x. So the distance that they go are going to be 75x and 95x. We want to know when they're going to be 442 miles apart, which means that when you add their distances together, because they're going in the opposite direction, when you add their distances together, that's how far apart they will be. So we want 442 to be how far apart they are. So we go ahead and add the like terms and divide. So it's going to take them 2.6 hours. So doing a table like this really helps. Let's see if we can do something like this. Carlos drove to the mountains last weekend. There was heavy traffic on the way there, and the trip took 10 hours. When Carlos drove home, there was no traffic, and the trip only took 7 hours. If his average rate was 18 miles per hour faster on the trip home, how far away does Carlos live from the mountains? Okay, so let's do our table. So we had, whoops, we had rate, and then we had time, and this is our distance, okay? So on the way there and the way back. So we know that on the way there, the trip took 10 hours, and on the way back, it took 7 hours. So if his average rate was 18 miles per hour faster on the trip home, so that means on the way, if he went whatever rate he went, it was 18 miles per hour faster. So we're going to add that. And then the distance, okay, we know the distance is the same for both of these. So on the way, he's going to go a certain distance. On the way back, he's going to go the exact same distance. So the distance here is rate times time, and the distance on the back is rate times time. I'm just going to put time first on both of them. We want these two to be equal to each other because he went the same distance. What's 7 plus 18? I mean, times. Let me just do this really quick. 126. So I'm going to subtract 7x here, and I'm going to leave my 126 there. And I get 3x divided by 3, which is 42. So x is 42. Now, it doesn't ask me what his rate was on the way, which is basically 42 miles per hour. And then on the way back was another 18, which is going to be 60 miles per hour. Doesn't matter. We didn't want the rate. We want to know the distance. So the distance is 10 times x. So we have to times that by 10 to get 420 miles. So he went 420 miles. Boy, this table really helps, doesn't it? Okay, we'll go to the next one. I'll erase this and we'll write another table. Two trains leave the station at the same time, one heading east and the other west. The eastbound train travels at 75 miles per hour. The westbound train travels at 85 miles per hour. How long will it take for the two trains to be 256 miles apart? So this is just like the example that we did to begin with. So we have rate, then we have time, and distance. And distance is rate times time, okay? So we have eastbound and westbound. I don't want to write out the whole word. So eastbound rate was 75, and we don't know the time. The other one is 85, and we don't know the time. But the distance is going to be 75x, 85x. We want to know when they're going to be 256 miles apart, and that's when you add their distances together. Can you guys see that? Like, they're going in opposite directions. Here's where they started. If this one gets here and this one gets here, when you add those together, you're going to get the total distance. So we want that to be 256. So we kind of add those together. 75 plus 85 is 160. So we just divide 256 by 160. It's 1.6. So it's going to take 1.6 hours. That's exactly what they're asking. How long? How many hours? So that's our X. So it's 1.6. I like to kind of double check. What is it they're asking? And did I answer it? Like, you don't want to be answering a question that they didn't ask. Okay, we have eastbound and westbound, 20 miles per hour slower than the westbound train. If two trains are 320 miles apart after 2 hours, what is the rate of the eastbound train? So let's draw our table. We have east and west again. Rate, time, multiply them to get distance. So we have east and west. 20 miles per hour slower than west. So if the rate of the westbound is X, then this is X minus 20. We know that the time was 2 hours. So the distance is 2 times X minus 20, 2 times X. And we know that when we add those together, we're going to get 320 miles. So we have 2X minus 40. I just did distributive property. So we have 4X. I'm going to add 40 to both sides. Is 360. When I divide by 4, it's going to give me X is 90. Wait, what was the question? What is the rate of the eastbound train? Okay, so I did X was westbound, so eastbound is take away 20. So the eastbound is going 70 miles per hour. And that's the end of the lesson.